Okay, I'll go ahead and get started. I'm going to go through mine relatively quick because it was really hard for me to sit through this at a certain point because we're dealing with so many of the issues from the regulatory standpoint in Arcata, and so we have a point of view on that. But what I really want to talk about is maybe another way to look at this, and this is things that we have been involved with here, Brad, myself, and other faculty and students at Humboldt, and also a lot of the work that we do in other places. And it kind of focuses on taking a whole different look at this. And I'm going to give you an example of going to a different place in the world where you don't have regulations, you have people that want to do the right thing. I want to make that point. Every group of either communities or a group of industrial people that we have worked with has wanted to do the right thing. I mean, so far, maybe I'm very lucky, we haven't found anybody that didn't want to do the right thing. And what we see happens quite often is people don't take advantage of the goodwill that's afforded by these people. And so I'm going to give an example as we get into this. Okay, so I am an old man, and I've been teaching for a long time. And, as I sit there, this is kind of my natural system perspective. The frog hanging on the leaf, and I'm looking, at the history of how we've tried to apply ecological engineering to solve problems, and how it's got very little acceptance by regulatory communities, by the engineering communities. By the way, if I fail to step on your toes, anybody here, raise your hand and I'll hit you for sure. I'm going to be very consistent and try to get on everybody, because we've had very little luck, to be honest with you. Brad and I have had some successes with convincing regulatory people and engineers to do the things that we think are a natural approach to solving these problems. It's a different place. Okay, I'm going to start with the Clean Water Act because I'm a kind of a baby of the Clean Water Act. It came into effect in 1971. It's what's driven my whole profession. And I had to keep going back to it because somehow when you see all these things that Mark went through, somehow I think they've lost the focus of the Clean Water Act. The Clean Water Act was really straightforward. It said something very, very simple. And the most important part of it, as you look at this, is they talked about zero discharge. And what they meant was not zero discharge of water. They said no contaminant discharges. Obviously, the water resource is an important aspect of it. And that was recognized. And so quite often, we see people not interpreting that, especially when we get down to the fourth one. He talked about reuse and recycle, that wastewater that's treated to the level that's necessary is a resource. It's your most dependable new source of water. It's sitting out there in your effluent right now. You know it's always there. If it gets to the quality that you can use it for a particular use, you should use it. The other important one is to help small communities. And I just can't keep thinking about it. I'm on a planning committee for San Francisco's Public Utility Commission. They have permitted discharges. They can discharge permitted disposals into San Francisco Bay. In 1968, I came to San Francisco to clean up the San Francisco Bay project, right? And that's, I don't know how many years ago that is, more than 30, right? And it's, and then I was caught up in another community participation activity there around Hunters Point, and I realized it has gone downhill. So the present approach in San Francisco, as it deals with stormwater and wastewater, because of their system, they have a combined system, they can't meet their discharge permits all the time because all their stormwater goes through their waste treatment plant, except when they have a quarter of an inch of rain or more, and then they have to buy for 24 hours. Over a 24-hour period, then they have to bypass. And so they're permitted to have those bypasses. So here is San Francisco Bay, the largest water resource from a standpoint of utilization, peripheral, that to me has just not really looked at it. And it's just, perhaps I don't think that's the way they should go. And they just can't put the pressure on a community that's certainly above the average income of the state. Okay, so the promises of the Clean Water Act, you have to keep them in mind because we keep forgetting about them. And the small community suggests that there are people who are really trying to do the right thing. I guess that's the point. Hey, go back here just a minute. I can't see my my button there. I got a different computer here. Okay. So when you start to look at how to approach these issues and in terms of natural systems, there's various scales, and the scales are really important. The scales have a cumulative effect. The scales also have different technologies and a different sense of stakeholders and communities, starting from the largest example that was brought up about the Klamath. The Klamath is 2 states, multiple players, complex problem is an example in this area, to ones that are just small watersheds, like in our area, the coastal streams, coastal areas, until you focus closer and closer to where you can do something. And at some point, you get down to the lot level. The lot level, there are things that can be done, and there's going to be discussions about that this afternoon. But it's this scale that's really important. Each one has a different stakeholder. No one's going to enforce what happens on your lot necessarily. You're going to do it because you want to do it. Let's start with that. Let's start that there's a way to activate communities to solve their problems without regulatory sticks. The sticks can be out there. They can be Phragmites or cattails, so they bend. Yeah, so they're not really hard sticks. Okay, they're soft sticks. So, a concept in ecological engineering, which is what we're looking at in terms of a lot of these technologies, is to look at natural system processes. And these start to understand those processes and how they're applied in the watershed is very important. I just talked to, yesterday I talked to Stan Harris. Some of you know Stan. He was the wildlife guy who helped us with the Marsh project. And I was talking to him over the fence. I was down there doing something. And we were just talking about this whole issue. He said, you know, conservation biologists were taught to just observe nature first. Not molecular biologists, conservation biologists. They just observe nature. The role that trees played with high groundwater, the movement of water through streams, how birds were attracted to things. He said, most of what I have learned, that's Stan talking, was just by observing things. Of course, he's a bird watcher, but he sees a lot of other things. And I guess I started thinking about that. I mean, and that's how ecological engineering concepts have started. People have observed how nature works. Nature has a way of processing most of the things we're talking about as contaminants, even dioxins. So there's ways that nature handles those things. Not that that's the only solution, but there are ways of handling sediment movement, transport, nutrient cycling, pathogen removal, or indicator removal, whatever the issues are. So that's the key. Natural systems says, let me look at the way nature does it. I'm going to try to emulate that in my watershed or in a point source treatment, whatever. So, the watershed approach is something like this. Because it's so complex, and I'll talk about that in a minute, is how to manage these kind of, I call them the inconsistencies in these planning efforts. You got different scales, kind of overlap. A bunch of circles. At the bottom, you got the lot. At the big circle, you got the Klamath River, for example, or the Mad. So it's really in a way of trying to put these together, and not to institutionalize. That's what really worries me. Institutionalizing watershed management is the kiss of death. And I'll give you an example of that, how it can be. I want to know what governments can do and what they can undo. I want to undo some government. I would like to suggest some things, if I could use your PowerPoint just to blot things out there. I'd like to undo some of the things because I think they've been counterproductive in terms of what they're doing. And the best example has already been brought up, and it'll be brought up again because of the wetland issue. In most cases, when it comes to using nature to do the work, it's the approach that's quite often taken is to kind of, what I say, landscape, to make it look like it did, rather than how it functioned. And that came up with what Greg was talking about. There are functions in the watershed that you need. You want something to work, to do something for you. It's going to be a wetland is a kidney, for example. Where can I place that in the system? It might not be where it existed to begin with, but it's in an area that can be used. And it's for sure not up on top of a mountain. We had a project in Willits where the mitigation site, the only place that they wanted the wetland to go is up on top of the mountain. I said, oh, wait a minute, what's this going to function up there for? Well, it was the only site we could find. I mean, it didn't go. But, I mean, that's the example. In other words, you know, things just didn't make sense in terms of putting the function relative to where you could use it, but not necessarily landscape it, not make it something that just looks like a wetland, figure out what the functions are, find a place to put the functions. You might have to put them different places. You might have to have, you know, territorial imperatives by whatever I can find to put the functions in. So here's the test. Watershed analysis fails if it becomes an end in itself. It succeeds if it orders and enlightens all the diverse array of activities that are done under the name of watershed management. There's an informal part of this that has a very strong public participation component. That means all the public, not the institutionalized. Not institutionalized, that's not the right word. Not the public that has been placed in a representative of an institution. So this is the one I really like. This is USGS. For several decades, we have grappled with how land activities on federal, state, private land interact to affect hydrological and ecological processes. Well, my contention is this grappling has had this effect, a negative effect. With everybody trying to figure out how to do it in repetition, we have examples in the Klamath where we have people been working, millions of dollars are spent over 20 years, and they've made it worse. They've actually made the planning process worse because of the different entities. So one of the issues is, you know, stop grappling, because we kind of know what these natural processes are. Start finding opportunities to place them in what I consider strategic places in the watershed, whether it's your lot, your coastal watershed, your urban stream, whatever. Well, this is my alphabet sustainability soup. And I saw, we could have done one with Greg's, and we have all these acronyms, right? And I'm not going to go through them, but they all represent different approaches, but also interacting. Some of them interact, some of them don't. And I didn't want to use the acronym for my title either. I didn't realize what had happened until I had that I kind of backed into, no, backed in is not the right word either, but you know, just something inadvertent, totally inadvertent. But a lot of these are tools that can be used to do this. And the last one there, which is one you probably haven't heard of, but it's one that Brad's going to talk about. It's a decision tool that's being used to look at sustainable treatment systems. The water and wastewater treatment appropriate for reuse decision model. Okay, here's where we start running into problems. I call it the implementation gauntlet. Whoop, missed the T. An impediment to sustainability. These are all very real. We have run into every one of these in projects that we've worked on in California and to some extent in Oregon, with Oregon organizations here. Starting with local zoning and public health, regional board, Cal Fish and Game, Coastal Commission, Department of Forestry, State Board, CEQA, Office of Planning and Research, National Marine Fisheries, NOAA, Corps, EPA, non-government organizations. These all become like fences, and they're not in this order necessarily. They can come back and repeat themselves. They end up, instead of being an integrated approach to trying to solve a problem, they become what I consider obstacles, because their point of interaction with a project is really maybe not at the most appropriate time. You always would say, I want to get everybody involved at time zero, so we're right on the same strategy. I can tell you that hasn't worked. It has been very unsuccessful, and especially in this area. And the reason, and I'm not really sure why, I think it has to do with the agency's imperatives of, I'm not really sure. There's a turnover of staff that's an issue. There's also an issue with imperatives of being the last one to play. For example, CEQA requires you to look at alternatives and have responses from all the agencies. We have agencies that will not respond to that should, because we're not going to say anything right now. We're going to wait till later. Well, later means you've already spent money, you've used council people's time. I mean, we've seen where council people have been involved with trying to solve a local problem, have been totally bogged down, not doing the other things they should have done, costing millions of dollars, escalation of price. We had a project started in 1991, still hasn't been built. Still discussing what the project's going to be. Well, that's 5 or 6% over 8 years. So this gauntlet is key, and this is one of the issues. In California, if you talk to anybody, you talk to builders, communities, industry, they'll say it's out of hand. The permitting process and the review process is totally out of hand. So how do you do that? I mean, what do you do? I mean, you go to the same council people that are voting for new enforcement, right? That's kind of counterproductive. We need someone that can look at this process and figure out a way to streamline it so communities can do the right thing, learn about how other people have done the project, involve these people in the positive aspect, as was mentioned, rather than just the permitting process. And there are people that can help with that. Okay, sustainability. Whatever project is built is something that we feel, from the standpoint of the investment, just the infrastructure investment, is something that has minimum operational requirements, minimum energy, constructed relatively inexpensively, has natural system components to it. So it has these components. It has a resource component to it. It has a technical component. It has an institutional. And most important, it has a community. Projects that we have found to be most effective are ones that have involved the community and still involve the community. Arcata's the best example, but there's many other examples now. Petaluma is a good example. In the case of wetlands, we have quite a few other wetland projects around the United States. Right now, there's about 900 to 1,000. Kind of lost track on the database. If we put in stormwater, 800 to 900 wetland systems. And because of the nature of the projects, they are very attractive to community participation. It doesn't stop just with the construction, because they see it's got a use. So it's the use that keeps it going. It makes it sustainable. And that's kind of the environmental justice. There's an environmental justice aspect to sustainability, a very strong one. It suggests that there's a fair and equitable access to water and water-dependent resources and other related infrastructure. It's that access that's really important. We just had an interesting one. Lisa, this is just kind of a point about the no swimming signs. Okay, but I'll just make the point. I mean, we all understand why they have to be there. But Arcata has had access to parts of the waste treatment facility for 30 years that you could walk around. It has a sign, wastewater, vehicle, what is the other ones? Vehicles driving on this area. That's the signage. And it's signed from that standpoint. Because it didn't have any signage about no swimming, now, well, no one, as far as I know, has ever gone swimming in the Arcata, right? Or if they did, we never found them. So, you know, what it means is this community knows that. I mean, if you've designed that and worked on that, well, you know you don't go swimming there, right? And it's a good point about how a community looks at a project. Now, if it had fences all the way around it with concertina wire across the top, right, with X's on it, you know, someone would probably try to swim in it. That's what I would think. Okay, so how should we do this? This is, I'm not going to dance, but this is the graphic dance, the paradigm shift. Under those categories that I mentioned, technical, socioeconomic, resource, environment, I kind of look at the way that it's presently done or has been done in the past. And then I look at the way you can move that particular issue into a future way to look at applying that, okay? So for example, and this was mentioned, actually, I think Mark or Greg mentioned this. The first one, instead of using technology standards, use performance standards, okay? Now, basically what that means, a technical standard means if I have a waste treatment plant and process A can get the job done, that means process A has to be every place for the permit. Performance standard says if I have to take out all the coliform at this point, I don't care how you do it, just so you get all the coliform out. Well, that's the point, is the coliform, right? So that's the difference, a big issue. Because when you move to the performance standard, it's like, I think Mark said also, that people can be creative. Their imagination can kick in. They can figure out other ways to do it. They can take technologies that were used somewhere else in ag engineering or somewhere in another country that does the same thing. Just because US engineers don't read the literature doesn't mean that it doesn't work, right? Okay, the other one is the move from sophisticated equipment to appropriate equipment, types of equipment that are longer lived, don't have the same maintenance requirement. Moving from capitalization to sustainable natural system. A natural system is recapitalizing itself all along. That's the point. That's really the point. You're recapitalizing with a natural system. You're not having to reintroduce things, okay? Complex operations to simple. On the socioeconomic category, this is a big one. This is a really big one, I think. Moving away from the health department's perspective of protecting ourselves from ourselves, which is what health departments do, right? That's their job, right? From a healthy individual to a healthy community. Get the picture bigger. I mean, the role that wastewater can play in a community is much, much bigger than keeping people from swimming and drinking and coming down with some disease, gastrointestinal disease. That has to be part of it, but it's got to be bigger. It's got to be bigger. Going from centralization to decentralization are the ways that I can make a system work better by having smaller parts and smaller connections rather than bigger parts and bigger connections. What that says, that has a lot to do with sustainability. Because if a big system breaks, it breaks big. If little systems have probabilities of breaking, and this one breaks, but this one's still working, this one breaks, this one's still working, it's sustainable and comes closer to meeting your goals. The technology-based versus community-based, we talked about that. The other one, the societal cost, and this kind of came up with Mark's discussion too, about how to take a cost of meeting environmental requirement and make it a community opportunity. How do you turn that into a community opportunity? How do you take a stormwater system and make that a community opportunity? Then subsidized versus self-supporting. I'm going to do something here in just a minute to show you about that. Someone asked about the cost. I am not in favor, never have been in favor, of the construction grant funds, the monies that were given to communities to build waste treatment plants. It was a disaster. And even though everyone's a recipient of it, including Arcata, the original carrot was 85% funding from the feds, 12.5% from the state. That means a community could build a waste treatment plant of only paying 2.5% of the capital cost, but all of the O&M cost forever. So what happens? They built complex systems, they built bigger systems than they needed, and now, all of a sudden, kind of like, not quite like the bridges in Minnesota, we're 25 years into the investment, treatment plants are starting to fail, people are trying, well, where's the construction grants money? I mean, aren't you going to give us some money? Do this? Well, it's your community, right? Don't ask the feds to go up the hill and back the hill and get 10% back and then pay you. You know, it's a community project. Make it funded. And we got lots of examples in the world where that's the way it's done. Okay, that's just not unusual, where the local communities pay for their own infrastructure for water and wastewater. See, wasn't finished. Okay, resource environment. This is another big one. Moving from resource protection, which again is another aspect of the beneficial use approach in the mission of the state board, to resource enhancement. Let's turn that. Is there a way that I can use a technology and a solution to not just protect what's out there, but actually make it better? I mean, can I put cool water, high quality, into a stream that's a coho return stream? That's maybe 100% wastewater if it's needed. Or can I create wetland habitat? Or can I recharge groundwater that's really critical for some other aspects? Then, of course, the other one is energy intense to low energy needs. That's a characteristic of a natural system. It's driven by solar energy. It's either plants or organisms associated with the plants that are really doing the work, so you don't have to supply the same amount of energy in a natural system. And then going away from the discharge disposal concept to reuse reclamation. I'm on a one-person mission to make sure that anybody that talks to me doesn't call it the Arcata sewer plant. Okay? And I can't tell you how many times that comes up on committees I'm on. You know, a sewer is really a pipe anyway, so we're not really sure what they mean by that. You know, this, a concrete pipe going through something, chewing it up. I don't know what they. But it's a water reclamation plant. That's what it is. And in a lot of places in California, that's the signage. And you should correct them if you want to really be correct. Anytime you hear that, just help them learn that it's a water reclamation plant. And we're reclaiming it for a lot of reasons. We could reclaim it for more reasons in Arcata, but we're reclaiming it for a lot of reasons. Then the last one is technological approaches versus ecological approaches. If you understand ecology, you can take parts of that, move it into a treatment system, get the same work done, but understanding, here's the difference. This comes up with the reason Arcata is in part of their MMP problem. An ecological system follows ecology. So when it rains, it collects rain on top of it. When the sun's shining, it does more work when the sun's not shining with the algae. So it has, even though it's still meeting its permit requirements, it has some sort of a pattern that looks like what a pattern you'd have if you were growing something, except it's there all the time. So not having a permit that understands and is written to understand those variations is the problem. That's the real problem with Arcata. It just has too much rain on top of its 80 acres, so it has fresh water going in, fresh water going out, and it violates one of the permit requirements. I've simplified it, but that's basically it. That's the issue. Okay, so here's just some examples real quickly. Ecological resource environment. Everybody knows the Arcata issue, but in terms of their success, but it's really understated. You know, anywhere from 300 to 800 people, depending on the day. I mean, we have days when there are more than that. But because there's so many ways to get in the Arcata Marsh, you never see that many people. But when we used to do people counts along with bird count, we used to do bird counts all the time. That was important. Then we said, well, maybe we should do people count. I mean, that's kind of what it's about. So we did people counts. Lots of people, lots of birds, whatever. And there are people down there. There are people down there all the time. And actually the best security is to have people there. That'll keep most people from swimming, to be honest with you. I can tell you that, you know, unless they're out there at night. So as soon as you take the people away, then you have some issues. But the most important thing is people are learning. People learn about this system. Some people don't. I mean, the most interesting things, we used to do interviews. We haven't done that in a long time, but 5 or 6 years, we'd interview people down there, you know, person on a microphone, student go down, someone come biking by. Do you realize that there's wastewater in this marsh where you're looking at birds? I had no idea. Oh, how long have you lived in Arcata? Oh, about 3 or 4 years. I said, yeah, that's a wastewater marsh. A lot of people don't understand that. I mean, unless they get into it. So it's worth re-educating people. That's the other thing. It's a continuing process. There's new people come in to understand what that's about. Technical. These are just some examples. This applies to a wide range of applications. The picture on the left-hand side is actually a wetland system in Idaho treating acid mine drainage that has metals in it. The natural process there is metals tie up with sulfites. Sulfites are in sulfates and also in some of the other properties of the plants. So as long as that stays anoxic or anaerobic, the metals stay tied up. Well, that's the way it happens in nature. That's how you get certain metal formations, geologically, is tied up. So that's a technique that's been used for controlling very passive, very small scale, works. Then the Arcata Marsh with the plants. And then the one on the very right is a project in Arizona where nitrates and perchlorates are being treated with a wetland. Both of those can be converted, nitrates to nitrogen gas, perchlorate, which is a very low level, part per billion contaminant, can be converted to chlorides. And it's just a wetland system, just that simple. So case studies, real quick. We talked. Willits is the one that I've talked quite a bit about. It's the one that Brad and I have been involved with, not anymore, but since 1999. And it was really sad what happened. We had regulatory people making decisions, and then different people would come in, and a different decision was made. Every time they did that, there was another couple $1 million and more time. And council people their whole meetings were tied up either with the bypass through Willits or the waste treatment plant. They have all these other things they had to deal with. That was the sad part to me. The sad part to me was people who ran for elected positions, were trying to do the right thing, had a very difficult time working it out. And that doesn't have, it's happened in other communities too, but it's the one that I think of most. And then there was a discussion about the scientists in the state boards looking at some of the information. Well, we have some issues about the way the science is done. I'm trying to hit everybody now, right? Including myself. I mean, we've had some issues that we needed some interpretation. But there was some science that wasn't justified. We could not understand how if we could understood how they did it, then we could have responded to it. But it was very arbitrary. Then we talked about the cost change, the staff change. And I understand that it is an issue, but it really presents a problem that scans over 8 or 9 years. You have different people come in with a little different perspective and a little different way to interpret things. And everyone has had that issue. And then the cost overrun or cost increase. Okay, let me talk about another project. This is one I feel really good about because we're actually building something in less than 6 months, an appropriate technology solution in Mexico at a university. What you see there is a footprint of a university. Those little gray things are buildings. And the thing in the middle that looks somewhat geometric is a waste treatment facility built to treat waste from the community, from the university. The university president here, I almost extended myself comparing with somebody else, but I can't be, gotta be careful, wants to use this site to train university students to go work in Oaxaca Valley, working in small communities, 500 to 1,000 people, because they don't have any waste treatment plant and they're water short. They can't irrigate their corn, they're water short. So his idea was to make a mini Peace Corps concept out of, this is the University Autonomous Benito Juarez, Oaxaca, is a WAPO acronym. He wants to make it a focus for that. So he engaged students and faculty here, the Engineers Without Borders, to build something, to meet a need, a very specific need in a community. And it was basically using an anaerobic system, which is, the thing that looks like a hat right in the middle. And then down the middle is an oxidation pond with flows coming back in the wetlands on the side. So we're using common walls. This design has changed a little bit because of some of the construction techniques, but basically it's the same. It's been rounded. People didn't like my square corners. And the students came up with most of this, but it's been rounded a little bit. And then the water is used for on-site irrigation on the campus. No disinfection, subsurface irrigation, which is the only way they can use it. They're not going to disinfect it. But they need a high-quality effluent. They need an effluent that has low TSS solids, so they can use drip type of irrigation. They have to make sure the coliform have naturally died off and the pathogens, which is a natural way to do it. So it's a very natural system. And the part that, at the end of my career, I feel like we're going to build another one in a year. I'm so excited about this. We got students, we got faculty on the campus that are doing something very quickly. And I'm not saying, it's just the opposite here, where all the regulatory issues and the agency responses and consultations drag things out down there. we have a problem. We need safe wastewater treated, and we need water for irrigation, reuse. Well, the Arcata Marsh we've talked about. Okay, here's kind of the closure on Arcata Marsh. And I think this is the economic part. Someone asked, well, do we have money that the state can give us to do something different? Well, if you look at the bottom of this, the bottom layer is the green, is the waste treatment facility that was required as of 30 years ago, right? 1978, we were asked to upgrade. So it was upgraded. We had an issue related to that with the regional system, but we built the system. And it cost a certain amount of money in 1978. On top of that, we had values. That same piece of terra firma, we had passive recreation and parks, we had environmental education, we had carbon sequestration, we had increased property values adjacent to the marsh, we had public relations and community marketing. Now, every one of those I have dollar values for. And I can show you, in 2002, that wetland was worth $2 million a year from the difference in the cost savings between going to a regional system on the spit. The regional system was going to be out between where the two mills used to be. So that's the difference, the annual difference, plus all these other ones. And I don't have carbon sequestration in there, but because I don't have a good number yet. But when I get that, that's going to be another number. So it's very valuable. It's worth putting your own money into it because it's a park. I mean, it's going to be, it's a place where people can have passive recreation, the whole issue. So it does have economic value, and you can afford to pay for it. So I kind of have this is kind of my generic thing. So what is it about natural system? This is the hook for people. For the chemists, it's the biogeochemical effectiveness. They're very effective. You have both aerobic and anaerobic systems. You don't have to turn them on or off. They know when to do their thing, and they know when not to. It's amazing. You don't have to have a controller. Is it their simplicity that's interesting to you? Is it their elegance? I'm an engineer, so I don't see elegance, but someone suggested that elegance might be an opportunity, right? Is it their biological complexity? Is it the diversity of disciplines involved? This is an interesting thing. Wetland systems are going in all around the United States by landscape architects, ag engineers, geologists, civil engineers, chemical engineers. It's one of those things that is kind of moved out of the classic civil sanitary, which is a good thing, I can tell you that, because of some of the issues. It's moved to a broader aspect. Not that they're not involved in it, but it's attractive from that standpoint. It doesn't have this creative, imaginative aspect or the aesthetic qualities associated with them. So we have all these constraints and divergence. I'm going to go through these really quickly. This is what's keeping us from doing this. Divergent regulatory agendas, unfunded mandates, permits, moving targets, fines, moratorium, conflicting science, political insecurities. I mean political insecurities and political insecurities short lives. That's the other thing. When people only have a short vision politically. Regulatory discretionary decisions, permitting approval quagmire, bounty hunting NGOs. I have a problem with that. I have a real problem with someone suing a small community. We have examples with River Watch. I'm afraid it might happen with baykeepers. They're good intentions, but they hold back the progress of a community trying to do the right thing. Then there was the other one. You told me. Yeah, Brad suggested one. Oh yeah, the engineers. Yeah, us. Yeah, we're I didn't want to have to say it. I thought maybe he would say, yeah, we're one of the problems too. I don't know how I could forget that. Well, I keep forgetting I'm an engineer. Assessment. Okay, so the natural resources are diminishing at a very fast rate. Interesting enough, ocean rise is going to put pressures on those opportunities. A thing that worries me the most is the community participation is dwindling. So that's something the state board could do. The state board used to require that you had a committee. This is actually on the construction grant program. So I just said we ought to get rid of it, but that part was good. Because they said you had to have a committee in the community that looked at these issues. In the case of Arcata, they have a wetland and creeks committee that meets every month involved in those kinds of issues, not necessarily the wastewater side, but on the enhancement side. But you need something like that. You need ongoing aspects to that. So the community participation needs to be fostered and accelerated. And then I'll do the last one, because this is a comment from a member of a technical team. He was actually a volunteer fireman in Ferndale. Sat through a bunch of these meetings with regulatory people and engineers and said it appears that they're blind to the needs of the community and the reality of the situation. And that's because of issues of conflict between Coastal Commission, Corps of Engineers, Regional Board, a whole bunch of other issues that took away some incredible opportunities in this case. Well, the recommendations are pretty specific here. I would really like to see a regional board that had technical people that would also come at the same time as they're delivering the stick. They're coming to help you. As it turns out, they are the people who see a lot of the waste treatment plants. They can actually, they can pollinate, that's the right word. They could pollinate the different staff. I mean, Arcata has incredible staff of operators, and they would respond to anything. They would think about any new idea that would come in. They wouldn't close their mind to it. So there could be some technical assistance. In the old days, that's what happened. I'm going way back. The U.S. Public Health Service, who used to do these things on a federal level, they were really technical assistants. There was no stick. They would come around and help. Well, there could be an element like that. I understand why you need the stick. But you certainly need someone who can help do that. And to be honest with you, the consulting engineering community is not the best place for that to happen. They have a whole different objective. I mean, they have a bottom line to meet. The more studies they can do, the better, to be honest with you. So every time a regional board says do a study, well, I'm sorry, client, but I've been asked to do another study, right? And maybe the study's necessary, but what happens is it keeps the community away from thinking about where they want to go and some other ways they can attack it. So the systematic approach is obvious. Some better way of looking at the management of watersheds. Minimize lengthy contested agency board. This is an environmental justice issue, but it's also, I consider it environmental justice. I'm going to say this is kind of tongue-in-cheek, but there's no reason to go to Australia. Just go to a regional board meeting where there's a kangaroo court. Okay? And here's the reason I say that. I've gone to many of those, even though there's an open session in the first. I've seen people who were working hard all day, would sit through long meetings, and people wouldn't get to them to the end of the meeting. And then people say, I'm sorry, we just ran out of time. And they came there with an issue. They came there to respond to it. So the regional board, the board appointees are changing all the time too. I'm not sure what the status is now. Is it full board? Right now. But it is changing, and some people are more responsive than others, but it's a big deal. When someone says we're going to a board meeting, they're prepared, they want to go, they want to make presentations, they want people to hear their story. I don't think they're organized correctly for the community to respond to the board and the board staff. This is my natural system slide. The big thing we need to know is we don't know how these things work. And they cost money to do it, to monitor a natural system. In this case, Cal didn't quite make it. Cal kept jumping on the moon. We don't know. We got wetland systems, we got stormwater systems. We don't know if they're working or not. And no one's footing the bill to pay that. And it's absolutely important to get feedback to other agencies and other communities as how they work. What's the effectiveness of these things? It's like no one really, it's not that they don't care. They know it's going to cost money, but they're not willing to put that money into it, either from asking the community to do it or coming up with ways to fund monitoring. The biggest gap I see right now with these systems. Okay, thank you.